So welcome back everybody, and today we'll be studying about limits, and this is where the calculus section of our mathematics starts. So I want you all to pay close attention to what I'm going to say. So there are a certain type of numbers in mathematics which we cannot find solutions to. Those numbers can be 0 to the power infinity, 1 to the power infinity. I'll come to this one also. Then another one is an infinity alone, or another one can be 1 by infinity, and many other cases which deals with infinity and 0. Now you can say 1 by infinity, we can say it is equal to 0, but not at times in mathematics we can consider the same result. At such times we use the concept of limits to find it, what the value of a particular function is. So let's move further. The function, let us say, we shall start like this. There is let us start with the visualization on the number line. What does a limit mean? So limits are of two types. Let me write that too. Types of limit, and these two types are LHL, left hand limit, and RHL, that is right hand limit. So now what does this LHL and RHL mean? I'll make you understand that with the help of a graph that I'm going to draw. A number line. So let this be your number line, let this be your 0, let this be your 1, 2, 3, minus 1, minus 2, minus 3. And so now let us take case A, that is the value of x is equal to 0. And let our f of x be equal to, box of x, so that for conceptual clarity you'll understand what these limits is all about. So at such time f of x is box of x, that is equal to box of 0, that is 0. So this is something that we usually do, so not a lot of problem. Now let us take our case B. Approaching x 0, I'll write down 0, from right side. So now what does this mean? Approaching 0 from the right side. So this means that we are approaching 0 from a certain number which is here. So there is a number which is just little bit greater than 0, which we can say RHL equal to 0.0000000000001. So we can say x is equal to 0.0000000, and it goes on 1. So f of x will be equal to box x that we defined, and at such time we put the number 0.00001, which is equal to 0. Box of any number like this is 0. Now let's take case C. Approaching 0 from left side. So approaching 0 from the left side means that we are approaching 0 from a number which is on the left. So this is the left hand limit, and the number can be minus 0.00. No. Number is minus 0.99999, and it goes on. So minus, just a minute, it can't be 0.9 actually. The number just beside 0 would be 0.000001. Here would it be minus 1? Minus 1, yes, correct. We did it right. So at this time x would be minus 0.000001. No, actually it would be 0.9999. See, 0.1 would be somewhere over here in the minus, and then 0.2. No. Yes, no. We are correct. So this is the number which is just beside 0. And if we put this f of x as minus 0.000001, then the box of this function, that is, this indicates greatest integer function. So the box would be minus 1. So now there are two values. If we approach x from positive side, RHS, and x from negative side, so there are two values. So we can say function is not continuous. At x equal to 0, and that function f of x is box of x. And we have seen that in the graph also of box of x, greatest integer function, that it's a stepwise function. I'll still dot a graph for the one that don't know it, so that you may know. This is xy, and the graph goes something like this, 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 like this. This is then minus 1, 0, 1, 2, minus 2, and minus 3. It goes on like this. So at this point, a particular integer, the function jumps upward. At 0 you can see, just after 0 the function jumps at 1. And we'll discuss about continuity and all this thing, that how a function is continuous and all, in the next episode. But now what we wanted to understand was this. So now let us understand a particular thing, of fundamental theories, fundamental theorems of limits. And the first theorem being limit x tends to a, and there are two functions, f of x plus g of x. This opens up as limit x tends to a for f of x plus limit x tends to a for g of x. Now if they are in subtraction, then it goes if similarly. So limit f of x into g of x. There are these two functions of x. Then it becomes limit x tends to a f of x into limit x tends to a g of x. Now if it is like this, x tends to a f of x upon g of x, then it becomes limit x tends to a f of x upon limit x tends to a g of x. Now if a function is like this, limit x tends to a f of x to the power k, then it becomes limit x tends to a f of x to the power of k. And then if a function is like limit x tends to a f of x to the power, just a minute, f of x to the power of g of x, then it becomes limit x tends to a f of x to the power limit x tends to a g of x. I'll write like this and I'll make power. I'll also write power just for you to understand it clearly. And now if it is said that f of x is less than equal to g of x on deleted neighborhood of a, then limit x tends to a of f of x would be less than equal to limit x tends to a of g of x. Now an important property, limit x tends to a f of x is equal to limit x tends to a times f of x, which can also be written as limit x tends to a mod of f of x is equals to mod of limit x tends to a f of x. But the converse is not true. So now let us understand about the indeterminate forms that I was talking in the beginning. So the indeterminate forms are the forms that look like 0 by 0, infinity by infinity, then infinity, negative infinity, 0 into infinity, 0 to the power 0, infinity to the power 0, and 1 to the power infinity. These all forms are together called as indeterminate forms. So now there are some standard limits that we need to know. And this is where the most part of the chapter is. And we need to by heart these. So the first one being I'll just write bullet points. So limit extends to a, x to the power n minus a to the power n upon x minus a is equals to n times e to the power n minus 1. Second one is limit x tends to a, x to the power m minus e to the power m upon x to the power n minus e to the power n can be written as x to the power m minus e to the power m upon x minus a upon x to the power n minus e to the power n upon x minus a. Now we can individually put this formula and we get m upon n a to the power m minus n. And the third theory is if mod x is between 0 to pi by 2, that means x is between this range mod of x, then limit x tends to 0 sin x by x equal to 1 and limit x tends to 0 tan x by x is equal to 1. And then we can write it out as limit x tends to 0 sin ex upon x equal to a, while limit x tends to 0 tan ax upon x equal to a. And now the x is given here, x is in radians. And if you want to write it out in degrees, then limit x tends to 0 sin x in degrees upon x, use pi by 180, and similarly limit x tends to 0 tan x degree upon x can be written as pi by 180. And another important theory is limit x tends to infinity sin x by x is 0 and limit x tends to infinity tan x by x is 0. Another thing of inverse trigo comes in sin x and x tends to 0 sin inverse of x by x is equal to 1 and limit x tends to 0 tan inverse x upon x is equal to 1. Now important are these ones that I am just highlighting out because they are very much useful. Now let us continue. The next one is limit x tends to 0 e to the power x minus 1 upon x is equal to 1. And similarly limit x tends to 0 e to the power x minus 1 upon x is equal to log a to the base e. So now here a condition can be written as e is greater than 0 because log cannot take negative values of e. The next one being limit x tends to 0 e to the power x minus b to the power x upon x is equal to log a by b to the power e. Next one, limit x tends to 0 e to the power x minus 1 upon b to the power x minus 1 can be written as log a to the base b, which derives from log a upon log b both to the base e, and this can be then converted into this form. So it's easy not to prepare this many formulas. Now limit x tends to a mod of x minus a upon x minus a does not exist. This is very important. Then this formula is again important. X tends to 0. 1 plus x to the power 1 by x equals to e. And if we just put a log on left side, so it can be written as limit x tends to 0 log of 1 plus x by x is equal to 1. And now let's just put an unknown in this, like a constant. Another one which I prefer to remember is 1 plus 1 by x to the power x is e. Again put log x tends to infinity log of 1 plus 1 by x to the power base x is 1. So now out of these many formulas again, the important ones are this one. Just a minute, let me put the result in the box too. This one, then this one, then comes this one and this one. So these many results are very much important. Now let us discuss a little bit more, that is the theory of L'Hospital. This rule states that if f of x upon g of x is in form 0 by 0 or infinity by infinity, then limit x tends to a f of x upon g of x can be written as limit x tends to a f dash of x upon g dash of x. And now if this is in form of infinity by infinity or 0 by 0, then we can write limit x tends to a f of x upon g of x is equals to limit x tends to a f double dash of x upon g double dash of x. And now I am putting a highlight onto this because this is pretty much half of the chapter. Now you can see 75% of the chapter is covered in this. And these is where the most of the questions are asked. So L'Hospital is something that you should necessarily know in order to solve limits. So now let us go on and know some of the frequently used expansions. Number 1, 1 plus x to the power p is 1 plus px plus p into p minus 1 upon 2 factorial into x square plus p into p minus 1 into p minus 2 upon 3 factorial into x cube and so on. If mod x is less than 1, no, let me underline it, highlight it another color. Yes, the second one is e to the power x, that is 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus so on. And then we can write e to the power x as 1 plus x upon 1 factorial into log of a, of course, to the base e, plus x square upon 2 factorial log of a to the base e, the squared, and so on. And then log 1 plus x to the base c can be written as x square minus x minus x square by 2 plus x cube by 3 minus x square 4 by 4 plus, and alternately it goes. Next, log 1 minus x to the base c is minus common x plus x square by 2 plus x cube by 3 plus so on. Next is sin x minus x cube upon 3 factorial plus x to the power 5 upon 5 factorial minus x to the power 7 upon 7 factorial plus x to the power 9 upon 9 factorial, and alternatively plus minus goes. Then cos x is 1 minus x square by 2 factorial plus x to the power 4 upon 4 factorial minus x to the power 6 upon 6 factorial plus x to the power 8 by 8 factorial, and alternatively plus minus it goes. Then tan x is equal to x plus x cube by 3 plus 2x to the power 5 by 15, and so on. It goes on increasing, where the condition is x mod x is less than pi by 2. I'll underline this because this is also sometimes important in the question. And then another series that I want you all to know is 1 plus x to the power 1 by x, that is e 1 minus x by 2 plus 11 upon 24 x square, and so on. So it goes on alternatively plus minus again. The last concept is the sandwich theorem or the squeeze principle. So it states that if f, g and h are functions such that f of x is less than g of x is less than h of x and may be equal to, then limit extends to a, f of x is limit extends to a g of x, and limit extends to a h of x. And we can say that if limit extends to a for f of x is equal to limit extends to a for h of x, and they are equal to some constant k, then limit extends to a for g of x will be equal to k. This is important, and this is a condition that is important in this theorem. This is also a very important and crucial part. And now the series out of this all is the series of e to the power x, frequently asked questions, e to the power x, frequently asked questions, sin x and cos x is a must known series, and it can be derived of course from the inverse trigger formula, but still remembering those is very much important as it saves time. And with that, we complete our chapter, and officially I'll write the end. Thank you, and do watch other videos of other topics. We'll meet again in another video.